Okay, so we're going to start off by doing this addition of radicals problem. Okay, so what do we do first?
You take the perfect square and the other thing out of it.
Okay, so how can we separate 20?
4 and 5.
Okay, how do we separate 45? Mm-hmm. And how do we separate 180?
I think it's like 36 and 5.
Oh. Okay. Now, what comes out from underneath the radical?
The 4, which turns into a 2.
Okay. What else?
9
Which becomes
turns into a 3.
okay.
And then the 36, which turns into a 9.
No.
No, I mean 6. My bad. No.
Okay. Now, multiply the outside numbers. Okay. And what do we get when we combine everything?
19 root 5.
Any questions on that?
No.
Okay, let's do number 10. Okay, what do we do?
You distribute
Okay, what do we get?
root 16 plus 4 root 6.
Okay, can we simplify this any?
Yeah, the 16 becomes 4.
All right, can we combine these?
Yep.
We can. We get 8 root 6.
Yeah, can't we?
Yeah, oh wait. No,
No.
wait, the 4 doesn't have a root 6 on it.
Right. Remember, in order to combine, they have to have the same number underneath the radical. Because,
Oh,
yeah, so they don't
Oh,
have,
I did that wrong yesterday.
huh?
I messed up yesterday on that part a little bit, but because I added them a couple times.
Yeah, you're only supposed to add when the radicals are the same. Okay. All right, so let's talk about multiplying. And we've been through this already, but it'll be a good way of reviewing, if you will. Let's say we have something like this, all right? Does anyone remember how do we do these?
don't you have to distribute it into each one?
Mm-hmm.
Isn't that FOIL?
Yeah, you can FOIL. So, you multiply the first terms, 2 times 1, which is 2. Then you multiply the outside,
2 and 8.
okay? Then you multiply the inside,
3 and 1.
and then you multiply the last.
Root 24.
Okay, and then you simplify. Which ones of these can be simplified further?
Root
The
24.
8.
Okay.
Yeah.
Root 8
Eight.
can be separated into what?
Root of 8 can go into 4.
Mm-hmm. Okay, and what about root 24?
That can go into 6.
Mm-hmm.
Or wait, no, not 6. Yeah, 6 and 4.
Okay. Okay. Okay, can we combine any of these?
No.
Okay, that's your answer. Any questions? All right, so let's do another example. Let's do multiply. Okay, what do we do?
Use FOIL.
Okay, so the first, what do I get when I multiply the first terms?
2 root 2.
Okay, then I do the outside, what do I get?
1.
Then the inside,
2 root 6.
positive or negative?
Negative.
Don't forget about your signs, okay? And the last,
Negative 1 root 3.
okay. Is there anything else I can do?
No, I don't think so.
Does everyone remember doing this in class?
Yeah.
Okay.
Yeah.
Now,
Kind of.
I know some of y'all have had an information dump, but it's okay. I'm trying to jog your memory.
No.
Now, here's a problem we talked about before we ended. Now, yes, you can FOIL, but what type of problem is this? Hold on one second.
Isn't it like conjugates?
Yeah,
I
they're
think?
conjugates, right? You're correct. They are conjugates. So
So you don't have to FOIL that.
you don't have to FOIL it. Remember, how do we multiply conjugates?
You do the first term squared, I think.
Right. First term
Times the
squared
second term squared.
minus the,
Oh, minus. Okay, second term squared.
correct. It's always minus the second term squared. So if I do this, what do I get? 1 minus, what happens when I square a square root?
It becomes like the actual number inside because it cancels out.
Mm-hmm. Let's see who's doing this one. Right. Any questions? So let's do another example. Solve. Okay, what do we get? What do we do?
We you do the same as last time and take the first thing squared minus the second one squared.
Okay, now. So let's do the second part first. Let's do this guy first, and then we'll come back to the first one. Okay. What is the square root of 3 squared?
3.
Okay. Now, what happens with the first one?
It squares both of them, right?
Right, it squares both numbers. So this is 2 squared times root 2 squared. Okay, so 2 squared is 4. Root 2 squared is 2. 8 minus 3, which is 5. Any questions?
No.
Okay. Now, it's important to know that conjugates undo each other. So remember, what did I say we don't like having in the denominator of a fraction?
Negatives.
Not only negatives, but what else? What do we not like having in the denominator here?
The
The
square root.
Square root, yes. So remember, when we just had something like this, how do we get rid of it?
Don't you multiply that to the top and bottom?
Right, you just multiply root 2 to the top and bottom, and it cancels out, okay? The radical goes away. Okay. Now, what about this problem? How do I get the radical out from underneath the denominator? And we talked about this before we left for spring break. Before we left for COVID.
How do we take that one out?
Mm-hmm.
Do you hold up? Since it's negative, don't you just move it to the top and make it positive?
Mm-hmm. No, only when the exponent is negative. This is not a negative exponent.
Oh.
So remember, when we multiplied the conjugates, what happened to the radicals? Okay. Well, multiplied conjugates, they went away, right?
Yeah.
So guess what we have to multiply here? We have to multiply, instead of just multiplying by root 2, when we have a expression like this, we have to multiply by its conjugate. Remember, when you have a binomial radical, you have to multiply by the conjugate to get rid of the radical. So numerator is 7 times 1 plus root 2. I'm writing it in parentheses to remind me to do the distributive property. And in the denominator, I get 1 minus root 2 times 1 plus root 2. Now, remember when I FOILed, this was a difference of squares. Okay. And the numerator I just distributed. Then, of course, as Lathan said, get the negative out from underneath the radical, out from underneath the denominator by giving it to the numerator. Does everyone remember doing that? Does anyone?
Not for real.
Not really.
Okay, so let's do another example. Let's go a little bit slower. Let's do another example. Let's do. Okay, so this is a binomial radical. Okay, binomial because it's two terms, and it's a radical because one of the terms is a radical. So we want to get the square root from underneath the radical, but we just cannot multiply by the square root of 3 because it's not going to work. So let's see what happens when I multiply by just the radical. Does that solve my problem?
No.
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 So we can't just multiply by a radical when we have a binomial. So this is why instead of just multiplying by the radical, we have to multiply by the conjugate of the binomial. And remember, just the conjugate is the same numbers, but in one they're added and the other subtracted.
So that's whenever you have a, like, because I know the other one, if it had just a square root, you just take the square root. When
Right.
do you do this? When it has
So-
a minus in it?
Yeah, so when we have a binomial, this is a binomial because it's two terms. Remember, binomial means two terms. So look, this is a 7 minus root 3. So this is a binomial when we have two terms like this in the denominator. If it's just a radical, if it's just one term underneath the radical, then you can multiply by what's underneath the radical. So if I had, like, say 5 over 2 root 3, this is, remember, this is not a binomial. This is just one term. So if you have this example, then all you have to do is multiply by root 3 over root 3 to get it out from underneath the radical. Okay. But when you have something like this, where you have two terms underneath the radical, when one or both is, when you have two terms in the denominator, and one or both of those terms have a radical, that is a binomial radical. So you have to multiply by the conjugate. Okay. And when you do your math, making a little bit of sense.
Yeah.
Okay, let's do one more. Simplify. Whoever wrote that, can you help clear it out? Thank you. All right, now, how do we do this? What do we multiply both the numerator and denominator by?
I thought that was, you could only see it on my screen. Sorry.
No problem.
You do it by the multiply it by the what's on the bottom.
Okay, well, by everything on the bottom, so 2 root 7 minus root 3?
Yeah.
No, we don't multiply it by that.
Or plus root 3, not
Yeah,
you do
multiply
it by
by,
the conjugate.
we multiply by its conjugate. So we're going to come back to the numerator in a second because that's the distributive property. I mean, that's the, we have to FOIL the numerator to get, and we're going to focus right now on the denominator. So what do I get when I multiply 2 root 7 minus root 3 times 2 root 7 plus root 3?
Do you get 4 root 49 plus 3?
Okay, so this is 2 squared root 49 or root 7
Yeah. It goes back to 7.
minus 3. Okay, remember it's always minus the other one. So this is 4 times 7 minus 3, which is 28 minus 3, which is 25. So the denominator is 25. Okay. Now, what do we do for the numerator?
You just multiply using FOIL.
Okay. So we multiply the firsts, we get 4 root 7. Remember, we multiply the outsides and we multiply the insides. Okay. So since there's no insides on the first terms, yeah, we just multiply the outsides. Then the outside terms, which is 2 times root 3, which is 2 root 3. Then we multiply the inside terms, which is 4 root 14. And we multiply the last terms, which is 2 root 6. Can we combine any of these?
No.
Can we simplify any of these?
No.
No.
Okay. Okay, any questions on this?
No.
All right.
Mm-mm.
Okay. So the last thing I want to talk about was the rational exponents. So we had to talk about this. So we said, remember, exponents can be whole numbers, but exponents can also be fractions. So a to the 1/2 is the same thing as the square root of a. A to the 1/3 is the same thing as the cube root of a. Okay. So we talked about this when we were doing our exponents section. A to the 1 over n is the nth root of a. Okay. Now, what does it mean to do the cube root? So first, remember this number on the outside of the radical sign is known as the index. Okay. And if there is no number, the understood index is 2. Okay. So remember, what does square root say? Square root says what number multiplied by itself gives me the radicand, this number right here. The cube root says something similar. What number multiplied by itself gives me the radicand? So for example, the cube root of 8. Well, what number multiplied by itself 3 times gives me 8? 2. Okay, 2 times 2 is 4, times 2 is 8. Okay. So this says what number multiplied by itself n times gives me the radicand. Now, let's say, for example, I have something like this. This is the same thing as the 4th root of a to the 5. Okay. So the denominator is your index. The numerator is the exponent of the variable. And when you have an improper fraction as an exponent, okay, when you have an improper fraction as an exponent, you can convert it into a mixed number. So for example, a to the 5/4 is the same thing as a to the 1 and 1/4. And another way of writing this is a times the 4th root of a. Okay. So a to the 1 and 1/4 is the same thing. You could separate this to a to the 1 times a to the 1/4. Which is this guy. So a to the 7/4 can be rewritten as a to the 1 and 3/4. Remember how to convert improper fractions to mixed numbers. So this is the same as a times a to the 3/4, and remember the denominator becomes the exponent or the index, and the numerator becomes the exponent. So this is the relationship between a rational exponent, fraction exponent, and square roots. Now, you can only do this when the fraction is improper, when the numerator is larger than the denominator. If the denominator is larger, when it's just like a regular fraction, like 4/7, all you can do is just rewrite it, remembering that the denominator becomes the index and the numerator becomes the exponent. Okay. And remember your rules of exponents, okay? So what happens when I have two exponentials added together, both with the same, multiplied together, both with the same base? What do I do with my exponents? Y'all remember this, the properties of exponents?
Don't they all add up then?
Yeah, so if the base is the same, you add the exponents if they're being multiplied. And when they're being raised to an exponent, you multiply the exponent.
Yeah, and then you multiply it.
Right. So this works whether the exponents are whole numbers or if the exponents are fractions, okay? So say, for example, I have a to the 1/2 times a to the 1/4. Make sense? And you're gonna have to practice with this. There's plenty of problems in the next section in Edgenuity that will give you more practice problems with this.
How'd you get 3/4 when it was just 1/2 and then 1/4.
So what's 1/2 plus 1/4?
Oh, I thought you just added like 1 + 1 and 2 + 4.
No, you do not just add the numerators and add the denominators. Nope. You have to find a common denominator when you're adding fractions. Remember
Right.
that? Now you can use this to simplify. So say, for example, I have something like, you can rewrite this using exponents. So remember the exponent becomes the numerator, the index becomes the denominator. There we go. Again, this is the, I think the assigned, this is the assigned instruction for today. Yeah, so today, radicals and rational exponents. So that's what we're going to be talking, you're going to be talking about today in your Edgenuity if you've been keeping up. And I want you to practice with that. I know I went through it pretty fast. I will be going more in depth with it in the afternoon lecture as well if you want to come in and attend. And practice with the problems, and then we will go over some problem types tomorrow.
I have a quick question. Is this meeting at 9 and 1 every day?
Yes.
Okay.
And so I will always send out the link like a few minutes before the actual meeting starts.
Okay.
Okay. Anyone else have any questions?
Are we gonna have to? You said we were pretty like we were filled with a lot of work for this week, but are we gonna have assignments every day for next week?
So next week, this is the calendar for next week. So next week, your test is Tuesday and Wednesday. So you have to do the test either on Tuesday or on Wednesday, or you could take the test Tuesday, and if you don't pass, you can have to do the retake on Wednesday. And then, yeah, you can see the assignments. So it's a little bit.
Can you just take the test like on Edgenuity?
Yes. So when you finish the assignments, I'm going to get a little asterisk next to your name saying that you're ready to take the test, and I'll unlock the test for you. Make sense?
I got disconnected for a few seconds.
Yeah. So next week is your test on all of these radical problems and stuff.
All right.
So when you get done with all of this properties of radicals and all, I'll get a flag or something next to your name saying that you're ready to take the test, and I will unlock the test for you.
Okay.
All right. Any questions?
Nope.
Right. So if there's no more questions, I will see y'all either tomorrow or this afternoon if you decide to attend.
See ya.
All right.
Bye, Mr. D. Thank you.
Thank you.
Bye, Mr.